Thank you.
Good afternoon. While pursuing our master's degree in archaeology at the University of Burgundy, Dijon, France, and Paris-Sorbonne University, Paris 4, France, we studied respectively textiles from the archaeological sites of Brandon-Oisan in France and Yakut's grave in Siberia. The study of archaeological textiles has revived thanks to a new generation of researchers throughout Europe and the world. In France, the interest in textiles began in the 19th century in parallel to the growing curiosity for archaeological research. Textile researches may focus on iconographic, technical, or anthropological aspects. However, it is the technical study that presents the most significant interest to researchers at this time. This paper's aim is to present several possibilities to study textiles and the wealth of information that can be learned according to issues. Indeed, much of the work done today concerns both identification of plant and animal materials used as fibers and dyes.
With two examples, we will see a comparative scientific approach of two techniques, one using several manipulations and one employing a more classical approach with fewer computer tools. The difference between these methods depends on means available and issues. In the first part, we present the context of two archaeological sites. Then we develop the two techniques employed for the technique analysis. We conclude with a brief presentation of the results and perspective. Brandon-Oisan was a medieval mining village located at around 60 kilometers from Grenoble, in France. The discovery of the archaeological artifacts allows us to date the site between the 11th and the 14th century. Particular conditions conserved a huge quantity of organic materials such as leather, wood, and textiles. In total, 1,335 textiles were discovered. The village was composed of houses, a church and its graveyards, a fortified house, silver and lead mines, as well as industrial districts linked to the treatment of the ore. Textiles studied here come from the B102 zone located at the northwest of the village. This area has revealed buildings with washing basins outside and inside of the constructions and pipes. 445 fragments, fabrics, and threads from this zone were analyzed.
Yakutia is situated in the northeast Siberian and covers a vast area of 3 billion kilometers. Founded in 204 by Éric Rubézy, the MAFSO, la Mission archéologique française en Sibérie orientale, aims to study ancient DNA. On the field, the MAFSO organized 3 triennials in 3 regions in Yakutia: Central Yakutia, Beloui, and Verkhoyansk. As the investigation has had the opportunity to be extended, the French team moved to northern Siberia. The good conservation of perishable materials, in particular textiles, is due to the permafrost, permanent frozen ground, remains characteristic of the Ice Age. Concerning the history of this region, the Russians began colonization of Siberia in the middle of the 16th century during the reign of Ivan IV. The primary goal of Russian colonizers was the search for raw material, including fur, through taxes named yasak. The conquest of Yakutia also had another purpose, another purpose. Throughout the 18th century, Russia conquered Siberia as far as the Amur Basin. At this stage, it came into contact with a powerful neighbor, China. The Russian Empire wished to establish trade relations with the Chinese Empire and sent diplomatic agents. So, the Russian Empire had a double benefit with the colonization of Siberia. First, it opens new territories and containing valuable commodities. On the other hand, it came into direct contact with China and started to trade with it. Textiles studied during my master in archaeology are dated between 18th and 19th centuries. Dating was carried out by different chronological methods. carbon-14, the chronocultural data, and dendrochronology.
First, the establishment of a textile corpus dedicated to technical analysis is carried out by sampling. Most often, textiles found in archaeological contexts are poorly maintained and are in the form of fragments. However, in the context of the Yakut textiles, samples were taken on larger parts. Samples are selected based on research issues and on the proper storage of materials for delivery of a lot of information. After the technical analysis, samples should be kept in a dry place. We wish to draw attention to the importance of a good non-polluted textile facility in both the archaeological field and the laboratory.
Once selected, each textile was photographed front and back. The photographs were taken with natural light and with a scale. The first technical survey put the archaeological object from a state to a three-dimensional image in 2 dimensions. The technical analysis of textiles is an observation of samples at different scales. Foremost, the textiles are observed with the eyes to describe the appearance.
For Brandon-Noison, the technical analysis is the first step to study a corpus of archaeological textiles. To realize this operation, it is necessary to note several pieces of information on every fragment of textile. Textile ID, its nature, textile or fabric, its measurement. For the warp and the weft, its meters, number of threads per centimeter, direction and degree of twist, diameter, colors, and, if possible, the maximum length of the threads. If there is one or several seams, the meter, diameter, sewing stitch, direction, and degree of twists, color of the sewing threads have to be noted. If a decoration is seen, its type, its structure, and a description should be signaled as a schema of the sample with the important element, seam, decoration, border, warp direction, etc. It is also possible to reserve an area on the technical record for the form, finishing, conservation state, packaging, and an interpretation if these points are significant. Potential remarks can be noted as well. These steps are realized with several tools. As a part of a classical approach, the thread count and the diameter were noticed with linen testers. One graduated in millimeter and another one graduated in 1/10 of millimeters. Details of fabrics were observed and photographed with a stereo microscope and a camera. Then, plans were necessary. They were realized manually on transparent plastic sheets and felt pens. Then information was entered into a table.
For the other technique, we note the same information. As part of a textile laboratory analysis, we also use an integrated CAM, a DIR microscope, which allows, through an image capture software, the taking of photographs. They allow us to identify the weave and to document the characteristics of threads. Picture quality depends on the brightness, but also the resolution and the camera field of view. As part of the study of the Yakut textiles, 2 image software were used, BCell and NXD. This software can also measure the diameters of the thread. In addition, elements constituting the spinning, direction, and degree of twist, the yarn structure. The weaving and the color emerge from this second stage of observation. Sketches of the collected textile are made to locate the collection in an orthonormal. Threads parallel to the x-axis are called the OX, and threads parallel to the y-axis are referred to as OY. As classical study of fabrics, we count the number of threads, OX and OY, by centimeters. These elements provide information about the density of the thread when mounted on the loom and can provide data about weave structure. After this step, we remove some thread from the textile fragment. When it is not possible to distinguish a difference in constitution between the warp threads and weft threads, a single thread is selected by textile. Then, each thread is decomposed using two grippers to separate the fibers. These fibers are deposited between a slide and a cover slip with a drop of distilled water and observed under a microscope. These longitudinal views allow an initial identification of animal and plant fibers. To determine the quality of thread, the degree of maturity of plant fibers or the species of animal fibers, certain textiles require an observation in cross-section. To realize this view, the selected thread is inserted into a hollow plastic rod containing resin mixed with a catalyst and an accelerator. Then, it is transferred by capillary action into the plastic rod. Once become a solid block, the rod removed and the block is placed vertically in a manual microtome. The latter is used to produce cuts of very small thickness, a few microns, for observing microscopic sections of the fibers. From these different stages of observations applied to samples from the Yakut clothes, data were first recorded on paper grid, and a database was designed to present the most information: photographs, measurements, sketches, dimensions.
Other analyses were made with the help of Christophe Moulera at the Quai Branly Museum in Paris. No pigment analysis was realized. Nevertheless, traces of blue and red dyes were seen on 14 textiles. 11 tabbies and one twill had a beige background and red weft-faced bands. Two 1 twills had a blue background and a beige weft-faced tabby bands. Fibers from colored threads were observed under a microscope. This observation showed that fibers were not completely soaked in the middle. A scanning electron microscope, SEM, was used to observe and photograph threads from 5 fabrics and plant matter with a high magnifying power. The SEM observation allowed to highlight the worn aspect of the surface of the wool fibers and to show the presence of a layer of sediment around fibers. Finally, analysis of chemical components from this envelope were made with the SEM and combined software. Lead is the most represented with rates between 4 and 48%. Barium and silicon are also present in huge quantities. Barium is a component of the barytes, element sometimes found in the vein or rock of Brandon-Oiseau. Silicon is combined to the quartz, sometimes present too in the vein or rock. Silver appeared briefly on screen. Nevertheless, the rate was too weak compared to the scale used.
Analysis of samples found in Yakutia was able to demonstrate the diversity of animal fibers, wild and domestic silk, wool, hair, and plant fibers, cotton, linen, but also the diversity of weave, tabby, twill, or satin. There are 2 silk categories: domestic silk and wild silk. In both cases, and whatever the species, the worm produces silk thread to make a cocoon, in which it is transformed into a butterfly. The cocoon is formed by a wire network. The shapes, colors, and sizes differ depending on the species of the worm. However, the cocoon wire is fragile, which is why it takes many cocoons to form a silk thread. Domestic silk is produced by the species Bombyx mori, which is native to China. To the naked eye, Bombyx mori silk has a shiny appearance. Viewed longitudinally, fibers resemble regular tubes, and they do not exhibit twisting. In cross-section, the fibers have a triangular shape whose vertices are rounded. The wild silk threads are from cocoon spun by wild or semi-domesticated silkworms. There are several types, but the best known are the antheriaria.